Muppli from DBS Institute of Technology, Kavali. So now we're going to the fifth unit, that is graph theory. So under this graph theory, what are the different contents in this graph theory or that? So basically this graph theory, there is some network topology is there, and some of the definitions about this network topology, what is node, what is branch, and what is the graph, and what are the different trees, twins, cards. Some of the definitions must be there. And the next one we go about the what is the incidence matrix, and then what is tie set matrix, and what is cut set matrix, and what are the different nodal and mesh analysis must be there. So before going to this graph theory, so we have to go about the why you have to use this, what is the main advantages of this graph theory must be. Basically network analysis is nothing but finding unknown branch currents or voltages across various branches. So to find out the unknown parameters by using different network applications, already we have to see about that what is Kirchhoff's laws, and what is the loop analysis, what is nodal analysis, what is the star delta transformation, and what are the source transformation technique, like that you have to see. But the mesh analysis and the nodal analysis are the most useful techniques for the analysis of the networks. So but the basic disadvantages of this technique is that the selection of the unknown variable is difficult. So the to know the unknown variable as the network becomes complicated. So hence in such cases the network analysis is made really simpler by using this concept called network topology. Network topology. So what is network? So network is formed by connection of elements at the nodes. It is a form of the connection of elements of the nodes. And topology is the layout of arrangement of elements. Layout of arrangement of elements. And what is a node? So node is a connection point between two or more branches. So a node means two or more points meet at one point is nothing but the node. And what is a branch? A branch means a line segment joined between the two connecting nodes is nothing but the branch. So a connection of total elements at the nodes is nothing but the network. So whatever the network must be there, that network is framed in the form of the layout and the frame of the layout, that is called as topology. And what is node means the connection of between the two or more branches is nothing but the node. And what is the branch means branch is the line segment joined between the two nodes is nothing but the branch. So before going to this network topology, we have to see some of the definitions in the network topology. So what is graph? Graph means a graph corresponding to a given network is replacing all the circuit elements with the life. Graph means a collection of various nodes and branch. So what is the node? A node means it is a two or more points meet at one point, and a branch means a line segment joined between the two nodes is nothing but the graph. So a graph of any network can be drawn by placing all the nodes which are the parts of the intersection of two or more branches. So the graph means it is a when there is a number of elements must be there, either it will be the passive or the active elements must be there. We have to connect in the form of a all the elements replacing in the form of the lines. Suppose if it will be the voltage source must be there, you have to short, and if it will be the current source must be there, you have to open. But any resistor, inductor or capacitor, whatever it may be, it is connected in between the nodes, then simply you have draw a line. So see, replacing all circuit elements with lines is nothing but the graph. What is the rank of a graph? What is the rank of the graph? If there are n nodes in a graph, then rank of the graph is n minus 1. If there are n nodes in a graph, then rank of the graph means n minus 1. And then what is oriented graph? What is oriented graph? Oriented graph means, so if suppose when the graph, I already tell that the graph means it is replaced in all the circuit elements with lines. What is oriented graph means representation of the arrows, that means representation of the directions, then it is called as oriented graph. So if each of the line branch of a graph has a reference direction, that means as indicated by a arrow, then the resultant graph is nothing but the oriented graph. So for each of the line branch of a graph has a reference direction, you have to assume the reference direction as indicated by an arrow mark, then the resultant graph is called as oriented graph or direct graph. How you have to, what are the steps to have to draw this oriented graph? So what is the steps means? So first you have to replace all resistors, inductors and capacitor must be a line segments. Whatever the connections must be there in between the nodes, if there is a resistor, if there is an inductor or capacitor, whatever is there, simply you have to draw in the form of a line segment. Replace all voltage sources by short circuit and current sources by open circuit. So you have to replace all voltage sources by short and all current sources by open circuit. Next, assume directions of branch current. So first you have to assume what is the directions of the branch current. So you have to convert in the form of the oriented graph. Next, name all the nodes and branches. So when there is a 4 nodes must be there, you have to put A, B, C, D. When there is different branches must be there, then there is put that branches are called 5 branches must be there, then you put 1, 2, 3, 4, 5, like that you have to assume the same. So replace all resistor, inductor and capacitor by line segments and replace voltage sources by short circuit and current source by open circuit. Assume directions of branch currents. Name all the nodes and branches. Next, so when you observe this, so this is graph. So this is one network. So in this network there is voltage source and there is 3 resistors must be there and 1 inductor must be there and 1 capacitor must be there. So node, first you have to assume the node. Node means 2 or more points meet at, and 1 point is nothing but the net. So how many nodes are? 1, 2, 3 and another one is reference node, that is the 4th one. So you put 1, 2, 3 and 4. It is first it is in circuit. Next you have to convert in the form of a graph. So next, for 1 to 2 there is a resistor. So you have to simply draw a line. And 2 to 3 also there is another resistor, simply draw a line. And 2 to 4 there is a capacitance, so simply draw a line. And 3 to 4 also there is a resistor, so simply draw a line. And 1 to 3 another inductor must be there, simply draw a line. And 1 to 4 there is the one what is that? Voltage source. Voltage source must be short and it will be the current source, you have to open. So simply draw a line. So it is called as, what is it? It is called as a graph. Now convert this graph as a direct graph. Direct graph or oriented graph. Oriented graph means you have to assume the directions. So we have first there is a graph and then it will be a circuit must be there. for the circuit, we have to convert in the form of the graph, and this graph is converted to the directed graph. So how you converted this directed graph? You have to assume the directions. So we have to, whatever the there is must be there is entering or leaving, whatever it may be, you have to assume the directions. Next, so from that oriented graph, what we do means, so we have, if there is a branches must be there. That means if there is the, how many nodes must be there? 4 nodes. 1, 2, 3, 4. So how many branches must be there? Branches means a line segment joined between the node. So 1, 2, 3, 4, 5, 6 must be there. So you have to represent A, B, C, D, E, F. Like that you have to mention. 3 topological equivalent graphs. This is already they have to represent in the form of the graph. In the form of the graph. That means, so when you observed here, there is the 4 nodes must be there. So 1, 2 there is the connection, and 2, 3 there is the connection, and 3, 4 must be connection, and 1, 4 must be connection, and 2, 4 must be the connection. So that means not only you have to represent this circuit in this form also, we have to represent. So here also 4 nodes must be there. 1, 2, 3, 4, 5, 6 branches must be there. Okay. So the same thing here also, 1, 2, 4 nodes must be there. 1, 2, 3, 4, 5, 6 branches must be there. So like that, here also 4 nodes must be there. 1, 2, 3, 4, 5, 6. 6 branches. So whatever the graph must be there, in this graph, you have to represent in any way. So whatever the circuit must be there, so you have to represent the graph in any way. But the connection must be, so whatever the relation must be there. If 1, 2 there is only resistor must be there, so you have to, there is only one connection. 2, 3 like that, and 3, 4 like that, and 1, 4, 2, 4, and 1 and 3 combination. Like that you have to represent the graph. Same thing. So here another simple example is there. So there is one voltage source and 3 resistors and 1 capacitors and 1 current source must be there and 1 inductance must be there. So here also there is 4 nodes must be there. 1, 2, 3 and 4. And for 1 to 2 there is resistor, simply line segment. 2, 3 also resistor, and 1, 3 there is the inductance, and 1 and 4 there is the resistance with the series with the voltage source. So simply draw a line, and 2, 4 also there is the capacitance. But when you observe here, 3 and 4 there is the current source must be there. So simply you have to open. Simply you have to open. So first one, A is the circuit. Next B, you have to convert in the form of the graph. And the C, what we do, we have to assume the directions. You have to assume the directions. So 1, 2, 3, 4, there is only 5 branches must be there, and 5 branches must be there, and nodes are 1, 2, 3 and 4. Like that. This is the directed graph. You have to assume the directions. What is planar and non-planar graphs? What is planar and non-planar graph? Planar graph means a graph drawn on a 2-dimensional plane is said to be a planar if 2 branches do not intersect or cross at point with is other than a node. That means if suppose 1, 2 will be connected, and 3, 4 will be connected, and 4, 3 will be connected. But for the same node, there is the another connection must be there, but that connection is not the overlapping. Overlapping means there is no any crossovers must be there. So then if it will be the overlapping the same node, then it is called as non-planar graph. If there is no overlapping is there, then it is known as planar graph. Planar graph means a graph drawn on a 2-dimensional plane is said to be planar if two branches do not intersect or cross at a point which is other than the node is nothing but the planar graph. So there is a simple example for this planar graph. And non-planar, a graph draw a two-dimensional plane is said to be a planar if two branches intersect or cross at the point. That means for the non-planar graph, if there is overlaps must be there, then it will be called as non-planar. There is no overlapping must be there, then it is called as planar graph. What is a path and what is a subgraph? Path means a set of elements that may be traversed in order without passing through the same node. So, whatever the elements must be there, that elements will be transferred without passing the same node. Say it does not pass with the same node, the elements must be transferred, then it is called as path. Then what is subgraph means? A subset of branches or nodes of a graph. It is a proper subgraph if it contains branches and nodes less than those on a graph. A subgraph can be just as a node or only one branch of the graph. One subset, one part of the graph, that means one subset or one branches of the graph, one part of the graph is nothing but the subgraph. When you observe that A is the graph with 4 nodes and 6 branches. So subgraph of this means, so I have take simple 4 and 5 is one subgraph, 1, 2, 3. This is one part of the graph. So if it is a subset of branches and nodes of a graph, proper subgraph, it contains branches or nodes less than those on a graph. It will be less compared to the graph is nothing but the subgraph. Next, what are the trees and twigs of a graph? Tree means it connects all the nodes but it does not form a loop. It's nothing but the tree. A connected subgraph having all the nodes of a graph without any loop is called as tree, and branches of a tree are called twigs. Twigs or links. Tree means a connected subgraph. It will be connected all nodes of the graph without forming any loop is called as a tree. And branches of a tree are called as strings. And branches of a tree are called as twigs. Next, what are the different properties to frame this tree? Depend upon this tree only all instance matrix, trisect matrix and cursor matrix, all you have to be done. So, tree means tree or twigs. Tree means it will be connected all the nodes but it does not form a loop. It's nothing but the tree. The remaining whatever the branches must be there, that is called twigs or links. So first, when you observe this circuit, one graph, there exists only one path between every pair of nodes in a tree. A tree contains all nodes of a graph, but when you have to draw a tree, it will be contains all the nodes, but it does not form a loop. If n is the number of nodes of the graph, there are n minus 1 branches in a tree. N is the number of nodes, n minus 1 branches in a tree. Tree do not contain any loops. It does not contain any loop. Every connected graph has at least one tree. For every connected graph, you have to, at least there is only one tree must be there. So, number of possible trees of a graph is minus A into A transpose. So, what are the properties? There is exists one pair between any pair of nodes in a tree. A tree contains all the nodes of a graph. If n is the number of nodes of the graph, there are n minus 1 branches of in a tree. And the tree do not contain any loops. Every connected graph has at least one tree. If you find the number of trees, A into A transpose. When you observe here, there are 4 nodes must be there, but 6 branches must be there. So, how you have to find out? You have to connect 4 nodes. But tree means connection of the all nodes, but it does not form any loop. So 1, 2, 4, 3 will be one tree. Other one 1, 2, 3, 1, 4, 3 and 2 is the another tree. So remaining whatever the elements must be there, that is 2, 3, 6, that are called links. That are called links. Tree branches is nothing but the twins. And here what are the remaining 1, 6 and 4 are the links, and 2, 3, 5 are the twins. So tree means the connection of the all the nodes, but it does not form a loop. It's nothing but the tree. Next, so identify trees in the graph. So this is one graph. So we have to identify the how many trees must be there. So first one 1, 2, 4, 3. There is another 1, 2, 4 and 3, and another 1, 4, 2, 3. Next one 2, 1, 4, 3. Next 1, 2, 3, 4. 1, 2, 3, 4 and 1, 4, 3 and 2. Next 1, 4, 3, 2. So 4, 1, 2, 3. Like that in all graphs, when you observe that there is no loop, but it connects the all the nodes. That is called as tree. Connection of the all the nodes, but there is no formation of the loop. Is nothing but the tree. So next, what is core tree and the links of the graph? Links or cores, it is called. And what is the links means whatever the remaining elements, remaining branches in the tree network is nothing but the links. The branches that are removed from the graph while forming a tree. Whatever the tree means that it will be connect all the nodes that don't form a branch loop. So what are the branches connected to the tree are twins. What are the branches removed from the tree are links. Links are complement of twins. So core tree means the graph consists with links is known as core tree. Only whatever the graph consisting of the links, that is called as core tree. Next, what is the incidence matrix? What is the procedure to form this incidence matrix? So first, what is the procedure to form this instance matrix means select a node at a time. So how you have to write down in the form of the matrix form. So when you have to represent the graph in the form of the oriented graph and write down in the form of matrix is nothing but the incidence matrix. What is the procedure to form an incidence matrix? Select a node at a time of given directed graph and fill the values of elements of instance matrix corresponding to that node in a tree. So first you have to select the node. Select the node and we have to whatever the elements must be there, you have to represent in the form of the lines, and you have to mention the directions and repeat all steps of the nodes of given direct graph. So you have to repeat this. So I take a simple example and how this incidence matrix will be formed. So find incidence matrix from the given graph. So you have to find the instance matrix for the given graph. They have given the simple graph. So how many nodes are there here? 1, 2, 3, 4 and branches A, B, C, D, E, F. And already they have given the directions of this oriented directions of this graph. So how you write down the incidence matrix for this graph? How you write down the incidence matrix for this graph? First, how many nodes must be there? 4. How many branches must be there? 6. So first, so this is the circuit. So how we write down the incidence matrix of this circuit? rows and the columns must be there. So we have to divide these rows and columns. So in this representation of the rows and the columns, so the branches must be taken, and then the rows must be branches and nodes must be taken. So 6 branches must be there. There are A, B, C, D, E, F, and 4 nodes must be there. There are 1, 2, 3, 4. So here we have to write down this in the form of the rows and the columns. So when you write down the incidence matrix, first what we do is, first if you observe that there is first node must be there. For the first node, how many branches are related? D, B and A. A, B, D are related to first branch. A, B, D are related to first branch. So next, for the second branch, what are the relationships there? B, B, C and E are related to the second branch. Next, for the third branch, what is the relationship of the third node? A, C, F. And the fourth node, what are the branches related? D, E, F. So one thing you have to assume that if you put if it will be related, the node will be related to that branch. Then if you put 1, if the K is associated with that branch, that means if when you observe it, the first node must be there. When you take A branch, A is coming towards the node, towards the first node. Then put it as -1. If it will be the away from the node, put it as 1. And it does not related to the node, put it will be 0. Put it will be 0. So when you observe here, the A is entering to the node, put it as -1. B is away from the node, put it as 1. And C I put it 0. Why I put it 0? There is no branch, C branch is not related to 1. And D is also towards the node, put it as -1. And E and F are not related, so put it as 0. Same thing. Second node, B are entering the node, put it as -1, C away 1 and E is also away 1 and the remaining must be 0. For the third node, B are entering to the node -1 and A and F are leaving, so put it as -1 and 1. And for the fourth node, E is entering, F is entering, so -1 and D is away, put it as 1 and remaining 0. When you observe that for each row there is -1 plus 1, 1 minus 1, 1 minus 1, minus 1, 1, 1 minus 1, 1 minus 1, then only the problem will be correct. So if that means each row must be goes to the 0, -1 plus 1, 0, 1 minus 1, 0. So then only the problem will be correct. So if the branch related to that node, then if it will be towards the node, -1. If it will be away from the node, +1. If it will be not related, put it as 0. If this is instance matrix, complete instance matrix. If I eliminate this last row, then it is called as reduced instance matrix. In some problems, they have given matrix and they have to write down in the form of the graph. Then you have to say that you have to take and they given the matrix in the form of reduced. That means they have to eliminate the last one. They have to given the matrix and write down the in the frame the graph. At that time you have to convert in the form of the incidence matrix and then you have to draw the graph. Next, this is another example. So here also there is A, B, C, D. 4 nodes must be there and the branches are 1, 2, 3, 4, 5, 6. So, for the A branch, what are the nodes related? 1 and 4. 1 is towards the node -1 and 4 is away from the node +1, and remaining it does not related, put it to 0. And same thing B. For B node 4, 5, 2 are related. 4 towards -1 and 5 is away +1 and 2 is towards -1 and remaining all not related 0. And C. For C, all nodes must be entering to the nodes. That is 3, 5, 6 are entering. So all put -1, -1, -1. Remaining 0. Already when you have to write down the 3 rows, 3 columns, then you have to observe here it is -1, last it is 1. -1, 1, -1, 1, 1, -1. All, then it comes to 0. 1, -1, it comes to 0. -1, 1. So like that you have to observe. This is called complete instance matrix. This is mentioned into AA. When you have to write down the reduced instance matrix, you have to eliminate the last row. Then it is called as reduced instance matrix. This is observed as A. This is observed as so A. This is about the graph theory, and what are the different definitions and what is the incidence matrix.